See that we have water that is available in space and time. Water varies in space and time. Sometimes we have more water available, sometimes less water available, and also from place to place, its quantity, it varies. Water available, it has the potential to be put into multiple consumption and use. So the water we are using for drinking purposes, we are using for cooking, washing, we are using water for industrial processes, we are using the same water for agriculture production. The same water in the rivers, they maintain our ecosystems. So water can be put into multiple consumption and use. For sustaining the environmental balance, you can see that when the water we use from our houses or from industries, we have to see that the quality of water is good enough before we discharge it into other bodies of water or rivers, because the same water can be used by other communities and it can lead to health hazards. For sustaining environmental balance, so we use the water, and after use, if we have to return the water to the environment, it should be good enough to avoid any environmental negative impacts. For example, we are using water from a river. We have to maintain some minimum amount of water in the river for survival of our ecosystem, and that is known as environmental flows. We use the water from ground sources, but the water that we use from the ground sources should not be too much that it can result into negative impacts. So water occurs in space and time with a feasible potential to be put into multiple consumption and use, and for sustaining the environmental balance. Water is a single resource. As you can see that it is abundantly available on the surface of Earth. It has no substitute. Water is a limited resource. Here we talk about the freshwater availability. Because we have plenty of water available in oceans, but we cannot use them. For example, directly we cannot use them for drinking purposes because of the salts present in it. So we are more dependent on water in lakes or in rivers. So water is a limited resource. Accessibility, how many people they have access to the fresh water? As you already know that civilizations have nourished along the banks of the river. Because water is life and we are using water for different purposes. So if we do not have direct source of water available, then we have to bring the water from a source to the community. So accessibility. If we do not have rivers, can we extract groundwater available in that area, and groundwater you have to pump. So the water that is available, either surface source or ground source, in how much quantity it is available, and what is the quality. By quantity we mean that if the required quantity of water is not sufficient to meet the demand, then we have to bring additional water from other source. For example, if surface water is not sufficient, we supplement that with the groundwater. This is a common practice. And the quality of water. For example, in Peshawar, we are extracting the groundwater and that is directly supplied to communities. The quality is good. But if we have, let's say, a surface water where quality is not good, so we have to treat the water before we supply it to communities. So water is a limited resource, and you see that accessibility, quantity, and quality aspects we have to explore. Water has social, economic, and environmental value. Because we use water for drinking purposes, for cooking, for washing, for our survival, water is critical. So that's why water has a social value. Water has economic value because the water that we supply to the community, we charge them. To the industries, we charge them. And this charge is necessary to successfully supply the water through the system, because you have to maintain the system, water supply system. The maintenance cost. So that is why water has an economic value. And it has environmental value because water sustains life on the surface of earth. All the plants and trees, they need water. Water in the rivers, in the lakes, they maintain our ecosystems. So you can see the importance of water. A unique resource. Every organism, individual, and ecosystem on the planet depends on water for survival. Water impacts all aspects of life on the planet. Poor water management and water shortages can lead to disease. If we have water shortages, definitely we cannot survive without water. Or if we have poor water management, for example, water stays in an area, so it can lead to causing diseases because it will become a breeding place for flies and mosquitoes. And an example. Similarly, if we have water shortages, it can result into malnutrition. Not sufficient diet that is necessary for health that will be available, because if we have water shortage, we cannot grow more crops and cannot meet the food requirements of the population. It can also result into reduced economic growth. For example, in Pakistan, Agriculture is the backbone of our economy. So if we have poor water management or water shortages, it will affect our economic growth. Also, it can lead to social instability. Let's say in a community, if water is not available, what the people will do? They will try to shift to another area. So that can result in social instability and conflict. For example, we have transboundary rivers. Let's say in our subcontinent between India and Pakistan, all the rivers that flow in Pakistan, they originate in India. So in the context of increasing population and more requirements for food production, you need more water to utilize. So the water in the rivers, they remain the same. The quantity throughout the year, that should remain the same, because you already studied hydrological cycle. The water moves in a cycle. So it can result into conflict. And India and Pakistan, they are times and again in conflict over the sharing of water in the rivers. And also, if we have water shortages or poor water management, it can result into environmental disaster. If there is no water, there will be no plants, there will be no trees which supply oxygen to the environment, which maintains the ecosystem. The rivers, if they dry up, you can see that the ecosystems that will be destroyed. So it can result into environmental disaster. Water resources. There are three resources of water. The first one is the rain, which is supplying water directly to any area on the surface of the earth. The second source is the surface water. So the surface water that is flowing in the rivers and the natural lakes that we have, or the dams, reservoirs that we build, so that can be a source of surface water. And we have the groundwater. So the surface water that occurs above the surface of the earth, and the groundwater that occurs below the surface of the earth. But the groundwater that is not directly available for use, we have to pump it in order to use the water. So it means we have three sources of water available to us. The rainfall that is directly supply the water to any area, the surface water which is in the form of lakes and the rivers, and the groundwater which occurs in aquifers below the surface of the earth. Next, we have this hydrological cycle. You have studied this in detail in your hydrology course. So hydrological cycle, as you can see, the water moves in a cycle. This starts from the ocean, driven by energy from the sun. So we have this evaporation, because oceans, they cover great portion of the earth, and due to the energy from the sun, evaporation takes place. And you already know that as the water vapor moves up, cooling takes place and it results into this cloud formation, and then the clouds, they move inland, and the same clouds can result into the rainfall. Or we have precipitation. So precipitation is a general term that include rainfall as well as snow on the mountains. Now this rainfall which occurs on the surface of the earth, some portion is absorbed by the plants and trees. So we have evapotranspiration. Evaporation plus transpiration. Evaporation from the adjacent soil and transpiration from the plant leaves. So collectively this is known as evapotranspiration, and the water is again transported to the atmosphere. Some part of the water that appear as surface runoff, that appears in the lakes or in the streams, and this result into stream flow, and the streams can ultimately drain into the oceans. So the water start from the ocean, again coming to the ocean. Another part of the water that infiltrates into the soil. So this is infiltration. So infiltration means entrance of water to the soil. So the other opposite is exfiltration. So infiltration is the entrance of water to the soil, and then the water moves through the soil profile, that is known as percolation. And this water through percolation and deep percolation can join the groundwater. And this groundwater at places can interact with the ocean. So you can see here the water moves in a cycle. This is known as hydrological cycle. So this is a main cycle with small sub-cycles. For example, here rain, evapotranspiration, again you see here the snow. We can have sublimation where the water changes directly from the solid state to the vapor state without passing through the liquid phase. Sublimation. So this quantity of water that moves in this hydrological cycle, that is constant. You see on the surface of the earth you have a fixed quantity of water. But it happens that because of the climate, the geography of the area, the variation of the quantities, they vary from place to place and time to time. So the hydrologic cycle describes the continuous circulation of water throughout our environment. As it moves from the oceans to the atmosphere and the land, eventually returning to the oceans once again. The hydrologic cycle is driven by energy of the sun and the gravity of the earth. Because you see that the water flows in the streams, that is the open channel flow, the main driving force is gravity. And proceed endless with or without human intervention. For example, you see here that we construct a dam, so we are regulating the flow. We are extracting the groundwater, bringing it to the surface, use it for different purposes. So this cycle continues with or without human intervention. The hydrologic cycle is also referred to as the water cycle, and the hydrologic cycle is actually made up of a series of complex processes and storages. So you can see here that this is the whole hydrology. Study of the occurrence, storage, movement, distribution of water. So you can see here we have surface water hydrology. If you study the occurrence, movement, distribution of water above the surface of the earth. Groundwater hydrology if it is below the surface of the earth. So it consists of these complex processes. You see that how evaporation takes place, what are the dynamics, how we measure the evaporation. We have the groundwater flow, it is a specialty in itself. How we measure the infiltration, the stream flow, how we measure the evapotranspiration. When rainfall occurs over an area, how we can measure the rainfall. If any missing rainfall, how we can determine the areal distribution, how we can calculate the missing rainfall in an area, and so on. So hydrologic cycle is actually made up of a series of complex processes and storages. Now the global view for occurrence of water, you can see that total global water, around 97% is in oceans. So 97% of the total water available on earth, that is in oceans. So we cannot use it directly for drinking purpose. So out of that, the fresh water that is available is only 2.5% according to this source. 2.5 fresh water available that we are dependent on for the different uses for domestic water supply, industrial water supply, agriculture, food production, hydropower generation. We are dependent on this fresh water, 2.5%. And out of this 2.5% fresh water that is available to us, around 69% is in glaciers and 30% is below the surface of the earth. If we make this 2.5% as 100%, so out of that around 69% is in glaciers and 30% is groundwater. So we are left with just 1.2% of this fresh water available. That is what is available to us for direct use. And this includes water in the lakes that we have, natural lakes. And we have ground ice or permafrost, 69%. And mostly that we talk about, that is the rivers, where the percentage of water available, that is 0.49% of the 1.2% fresh water that is available to us. So you can see that why we say that it is a limited resource. It's not that we do not have enough water on the surface of the earth, but it is that because the water that we can use for different uses most of the time. So you can see the quantity of water that is available to us. The fresh water, 2.5% available. We have frozen, that is around 69%. Groundwater is around 31%. And the surface water, fresh water that is available, that is 0.3% according to this source. So the figures can slightly vary because depending on the different sources, but this is how you can visualize the availability of water. So you can see that how much water, that is actually the fresh water that is available to us for different uses. And then for that, a greater portion is frozen ice. And around 31% is groundwater, which is not directly available. You have to pump. So this is the water that is available to us in the form of the soil moisture and the lakes and the rivers. So you can see that the fresh water that is available to us, that is in the form of aquifers, rainfall, natural lakes, reservoirs, and the rivers. See, and then we talk about the rivers in Pakistan, the Indus River, which is the lifeblood of the agriculture, and agriculture is the backbone of the economy of Pakistan. You can see that globally how much quantity of water that is available to us in the rivers. So that's why we say that fresh water resources is a finite and vulnerable resource. Vulnerable in the sense that it can be polluted. You might have studied that if we want to make the seawater as drinkable, it is very costly. For example, in Saudi Arabia, where the rainfall is much less throughout the year and the surface water availability is very low. And groundwater is also not available because you see that mainly they are extracting oil. So what they do is that they have desalination plants to remove the salts from the seawater and make it usable for consumption for different uses. It's very costly. For example, you see the bottled water, the cost is more because it is treated. But let's say, for example, in Peshawar, the groundwater which is supplied to the communities, the cost is less. We have flat rates. Per month, you pay very nominal charges and you can use unlimited quantity of water. The usage of water, that is not just like we using the electricity, where you are charged for each unit. But in water, per month, you pay some nominal charges that vary from place to place. And that also depend on the system of water supply. Just to cover the operation and maintenance cost, we need to pay the money for that. So this is how you can compare that the water that is available to us in the rivers that we will talk about mostly in this course, that we need to construct dams to store the water and we need to divert canals from the rivers for agriculture production. So you can see the quantity of water that is available. Next, we discuss water resources of Pakistan. So we studied that mainly we have three resources of water. We have the rainfall, the surface water in the rivers and lakes, and we have the groundwater. So in Pakistan, we are blessed that we have glaciers in the north that supply water to the rivers. Also, we have direct water from the rainfall. We have the rivers, Indus River and its tributaries. and the water is coming actually melting of these glaciers. And we have the groundwater, which we have to pump and then use it for different purposes. Pakistan has been blessed with a variety of water resources in the form of glaciers, seasonal precipitation, groundwater, and surface water. So we discuss first the glaciers. Significant part of the Indus River flow originates from Karakoram Himalaya, Western Himalaya, and Hindu Kush mountains. You can see that these glaciers, that exist on the mountains in the north of the country. So we have these Karakoram Himalaya, Western Himalaya, and Hindu Kush mountains. These are the ranges. So the glaciers here, they supply the water, the source of water for the Indus River and its tributaries. And Indus River is very important in the context of Pakistan, that the whole country actually depends on this Indus River and its tributaries. The glaciers carry great significance in the flow volume and timing of the Indus River and its tributaries. Why the glaciers carry great significance? Because during summertime, when the temperatures are high, these glaciers, they melt. And that's why the rivers, they carry more water during the summertime. So you can see that these glaciers have significance on the flow volume and the timing. During the summer, the flow volume is more in the Indus River and tributaries because of the melting of the glaciers due to the high temperatures. But during winter time, when the temperatures are low, the glacier melting is slow, and that's why the flow volume is reduced, clear, in the Indus River. The glacier runoff contributes approximately 24.1 billion cubic meter to the total annual flow of the upper Indus Basin. Upper Indus Basin, that covers the northern parts of the country, because the Indus Basin, it continues to the Indian Ocean or Arabian Sea. So in the upper Indus Basin, the glacier runoff contributes 24.1 billion cubic meter of total annual flow. This is volume, clear? So downstream, then there are tributaries that join the Indus Basin. Indus River. And this 24.1 billion cubic meter to the total inflow of the upper Indus Basin, 17.3 billion cubic meter from the Karakoram Himalaya, 2.8 billion cubic meter from the Western Himalaya, and 3.9 billion cubic meter from the Hindu Kush ranges. So you can see that glaciers, they play important role. And that's why significant studies are diverted to study these glaciers over the period of time in the context of climate change. Because the global warming that we much talk about, that is the increasing temperature of the surface of the earth due to greenhouse gases such as the carbon dioxide, the temperature of the earth is increasing, so these glaciers, they are melting. So when these glaciers, they are melting, in the beginning, 20 years, 30 years, 50 years, we will have more water in our rivers. But once the glaciers are finished, then these rivers, they will dry up and they will pose significant threat to our civilizations. Because you see that Pakistan, the agriculture that is mainly dependent on the Indus River and its tributaries, and the source is these glaciers. Next, we talk about the rainfall. So the regional distribution of average annual rainfall varies from less than 100 millimeter in Balochistan and Sindh provinces to more than 1500 millimeter in northern mountainous areas. You can see the variation of rainfall. You see that it varies from less than 100 millimeter in Balochistan and Sindh provinces. That's why those are semi-arid to arid regions. To more than 1500 millimeter in northern mountainous areas. So this huge variation between the rainfall is what it makes that we have to look for other sources to meet the demand of that region. If we have enough rainfall that we get directly the water to meet the crops demand, plant trees, and in addition we get enough water that we can store and use it for different purposes. But you can see here that the rainfall we will talk about in the context of irrigation, that we supply water to crops. So you can see here the variation of rain in Pakistan. About 70% of annual rainfall is received during the monsoon period. That is the months of July and August. So you can see that in Pakistan, 70% of the rainfall occurs during monsoon period. So in other months, then we have to use the water from the rivers or groundwater for different demands. Now we talk about the agriculture. So during Rabi season, which runs from October to March, it is less than 50 millimeter in parts of Sindh and more than 500 millimeter in Khyber Pakhtunkhwa provinces. So during the Rabi season, which is from October to March, mean the winter season. So it is less than 50 millimeter in parts of Sindh. So it means that rainfall alone is not sufficient to grow crops. This is the point to understand here, that why we need irrigation. If we have enough rainfall over an area where we grow crops, and that rainfall also occurs at the required times when the crops need the water, at that time we have rainfall and in required quantity, then this rainfall alone would be sufficient for raising the crops. Then we don't need irrigation. We don't need artificial supply of water for growth of crops. So this is the reason you can see here why we need irrigation, and we have irrigation engineering. Similarly, mean rainfall for the Kharif season, which runs from April to September, summer season you can say, varies from 50 millimeter in Balochistan to more than 800 millimeter in the northern Punjab and KPK. So you can see the variation. The extreme changing pattern of rainfall results in large variations in flows during the Rabi and Kharif seasons. Because we grow crops, during the Rabi and Kharif season, during summer and winter season, different crops. So you can see that because of the changing pattern of rainfall, we have large variations in flows during the two seasons. Due to this severe aridity, about 92% of areas of Pakistan are facing extreme shortage of water and hence classified as semi-arid to arid. Arid land where the rainfall is not sufficient to meet the evapotranspiration that requirements. Clear? So you can see here that 92% areas of Pakistan, they are classified as semi-arid to arid. So you can see that the rainfall, which is a source of water, that is not sufficient to meet the crop water requirements alone. About 16.5 billion cubic meter of rainwater contributes to crops. In the Indus Basin irrigation system, we will discuss this in detail, Indus Basin irrigation system, which is only 13% of the average annual canal diversions. So it means that the water which we are diverting from the dams and from the rivers for crops, the rainfall that occurs in the Indus Basin irrigation system, that is only 13%. 13% of the crop water requirements can only be met by the rainfall. So in order to produce more food for the population, we have to artificially supply the water to the crops. And this is known as irrigation. This is why we have the need for irrigation. All these figures are from the book Applied Irrigation Engineering that is published in 2017. So you can find updated figures about Pakistan. The groundwater situation in Pakistan. Groundwater provides an alternative water resource for agriculture. Why? Because groundwater is not directly available if the water table is sufficiently below the root zone, so plants cannot extract water. So that is why we have to pump the groundwater to the surface and then supply it through channels to the crops. And this is a very useful resource. It is estimated that around 33% of the world's population utilizes groundwater. So it means we cannot ignore the significance of this valuable resource. Many countries such as Pakistan, India intensively exploit groundwater to supplement the canal water. It means that we are using groundwater as a source to supplement in addition to the canal water that we supply for agriculture. The rice wheat region, that is central Punjab of Pakistan, is meeting 70% of their crop water requirements from groundwater. You can see here that in central Punjab, 70% of the crop water requirements are met from the groundwater. That's why they have extensive network of tube wells to pump the groundwater, and then it is supplied to the agriculture lands. In Pakistan, most of the groundwater resources are stored in alluvial deposits formed by the Indus River and its joining tributaries starting from the Himalaya mountain to the Arabian Sea. So this groundwater resources, these are stored in alluvial deposits, alluvium, anything that is transported by the natural rivers, the material. So you can see that the water, they transport these sediments from the north part of the country towards the Arabian Sea. So at times when the water slows down, these materials are deposited, and over a period of time, you see that they trap the groundwater, and now we have this groundwater resource. So most of groundwater resources are stored in alluvial deposits formed by the Indus River and its joining tributaries starting from the Himalayan mountains to the Arabian Sea. The Indus Plain area is 1600 kilometers long and extends over an area of 21 million hectares. This alluvial deposited plain has extensive unconfined aquifer. So you already studied in hydrology confined, unconfined aquifer. So unconfined aquifer, where the top surface of the water, that is water table, forms, that is atmospheric pressure. Unconfined aquifer, which is providing a supplemental resource of water for irrigation. Now you can see here that when we talk about the agriculture, so we have the rainfall which occurs over the country, but you see that there was large variations. So we have to artificially supply the water for agriculture. So the important source of that is the groundwater, which occurs. This is supplemental source of water for irrigation. This groundwater reservoir has been enriched by the direct recharge from rainfall. So how the water comes in this groundwater reservoir that we have in the Indus Plain? It is recharged from the rainfall, the river flow, because we have many rivers that flow, Indus River and its tributaries, so the water goes down and recharge the groundwater reservoir, and the continued seepage from the irrigation network of canals. So in Pakistan we have irrigation network, and you might know that the surface irrigation system of Pakistan, that is largest continuous irrigation system, largest in the world. Pakistan has the largest continuous surface irrigation system in the world. So we have many canals, weirs, barrages, dams that we have in this irrigation network. And plus we have those canals that we have constructed, distributaries and water courses. These recharge the groundwater reservoir since the last 90 years that we have developed this system. In Punjab and Sindh, about 79 and 28% of the area is underlain by the fresh groundwater. You can see here in Punjab, 79% of the area is underlain by fresh groundwater. That's why in Punjab, you will see that extensively through tube wells, they are pumping the water and use it for different purposes, including agriculture, which is used as supplemental irrigation pumped through tube wells. Next, we have the surface water. So the major sources of surface water contributing to the Indus Basin irrigation system are the snow melts and precipitation over the mountainous regions. So as we talked earlier, that the glaciers that we have in the north of the country, they melt and contribute water to the rivers that flow in the Indus Basin irrigation system. Runoff water through streams and rivers is stored in the reservoirs or diverted directly through canal systems to the fields for irrigation. So this water, this runoff water, which comes from the snow melt and precipitation over the mountainous regions through streams and rivers, either it is stored in the reservoirs that we have, for example, Tarbela Dam, Mangla Dam, or we have the weirs and barrages that we divert the water through canal systems to the agriculture fields for irrigation. Irrigation, artificial supply of water for raising the crops. The Indus Basin irrigation system primarily comprised of 6 rivers, namely Indus, Jhelum, Chenab, Ravi, Sutlej, and Beas. So in Pakistan, however, the surface water resources, because of Indus Water Treaty, which was signed in 1960, which is a water sharing treaty between India and Pakistan. So Pakistan was limited to the water of the Indus, Jhelum, and Chenab rivers. So as you have already studied about the Indus Water Treaty, out of the 6 rivers, control of the 3 eastern rivers was given to India, and control of the 3 western rivers that include Indus, Jhelum, and Chenab was given to Pakistan. So basically it means that even though we have the 6 rivers, mainly the Indus and its tributaries joining these, you can see here that not all of the water in the river that is available to meet their demands. That is why we have to supplement the surface water with groundwater. Considering the temporal distribution of water availability in the irrigation system, about 84% of the total annual river flow occurs during Kharif season, during summertime. You can see here that the surface water which runs in the rivers, 84% of the total annual river flow occurs during the Kharif season. So it means that you have enough water available for the summer crops. And about 16% during Rabi season, giving the Rabi to Kharif ratio of 1 to 5.2. You can see here that if the water one time is available for Rabi season, 5.2 times is available for Kharif season. So even if we have these rivers, still you can see that the temporal distribution, the time temporal distribution is not equal. It means that more water is available during the summer time, but less water is available during the Rabi season. So in winter, how we meet the requirements of the crops? So these are the reasons that why we have to construct dams. In irrigation engineering, why we study the dams? So that you can store the water that is excess, and then the same water can be released during the Rabi season to meet the crop water requirements. The crop water requirements, on the other hand, occur at a ratio of 3 to 5 between Rabi and Kharif. Thus, there exists incompatibility between the water availability and requirement. See, the requirements ratio is this, and the water availability ratio is this. So there exists incompatibility between the water availability and requirements. Particularly during the Rabi season, which has partially been regulated through managed releases from dams and reservoirs. So because of this incompatibility between the water availability and requirements, so during the winter season, the Rabi season, partially this has been done by regulating the flow that is releasing from the dams and other reservoirs. But that's why we study hydraulic structures. It shows that storing of water during high flows and releases during low flows through dams and reservoir is indispensable for sustainable agriculture. If you want to have sustainable agriculture, which means that you have the food production that meet the requirements of the present population, and also the future population. So we have to store the water during high flows and release the water during low flows. This is critical. Only then we can sustain our agriculture. And for this purpose, we have all this irrigation network, irrigation system, and we have Indus Basin irrigation system, which covers the entire country, which is a network of these storages and canals and other hydraulic structures. This is the reason why we study irrigation engineering. Next, we briefly talk about the Indus Water Treaty. So, as you already know that the water which flows in the rivers, these rivers, they flow through different countries. So it means that these are transboundary. So in Pakistan, we have transboundary rivers. For example, the rivers which flow into Pakistan, they actually originate in India. And with the increase in population, we need more water to grow the crops and more water for industries and water supply, drinking, cooking, washing purposes. So consequently, it will lead to conflict. And this happened in our case, in the subcontinent. In 1948, India stopped the water from the rivers entering into Pakistan, and the two countries were on the verge of a water war. So after almost a decade of negotiations, finally a treaty was signed in 1960, which is known as Indus Water Treaty, which gives India and Pakistan the rights to use the water of the 6 rivers. This is actually a water sharing treaty between the two countries. The Indus Water Treaty is a water distribution treaty between India and Pakistan, negotiated by the World Bank to use the water available in the Indus River and its tributaries. The Indus Water Treaty was signed in Karachi on September 19, 1960 by Indian Prime Minister and President of Pakistan. This treaty divided the use of rivers between the two countries. The treaty gives control over the waters of the three eastern rivers, that is the Beas, Ravi and Sutlej, to India, while control over the waters of the three western rivers, Indus, Chenab and Jhelum, to Pakistan. So because India has to use extensively the water from these three eastern rivers, there was a threat to agriculture and other water demands in Pakistan. So under this treaty, this also guaranteed 10 years of uninterrupted water supply. So Pakistan got 10 years to develop infrastructure to meet the shortages because of division of water usage of the rivers between the two countries. So during this period, Pakistan was to build huge dams, financed partly by the long-term World Bank loan and compensation money from India, because India has the full right to stop the water of the three eastern rivers. So three multi-purpose dams, Varsak, Mangla and Torbela, were built. A system of 8 link canals was also built, and the remodeling of existing canals was carried out. So we have 8 link canals. Link canal means it is linking two rivers. For example, you want to divert the river water to another river, that is done through these link canals. So because some of the rivers, the India has full control over the water, so in order to compensate, we have these link canals that can supply the water from one river to another river if we need more water in the river for meeting the water demands. Five barrages and a gated siphon were also constructed under this treaty. The treaty allows India to use the western river waters for limited irrigation and unlimited non-consumptive use for such applications as power generation. So India has full control over the three eastern rivers, but the western rivers, which also originate from India, under the treaty, India is allowed to build run-of-the-river hydropower projects. You might have heard the name Kishan Ganga and Baglihar Dam. So these are actually run-of-the-river hydropower projects. These are allowed under this treaty. Because here India is not storing the water, these are run-of-the-river projects. Just like we have the Ghazi Barota hydropower project. It is run-of-the-river project. It is basically a canal, a channel which runs from Ghazi to Barota. And at Barota, then head is available, and we have 5 Francis turbines that can generate electricity 1400 plus megawatt. Just like this, under the treaty, India is allowed to build hydropower projects till the water downstream can continue to flow into Pakistan. Even though Pakistan has raised concern over construction of these projects, but so far we have not been successful in the International Court of Justice, because you can see that India is allowed to build hydropower projects under this treaty. Similarly, we have the Water Accord 1991. So we have the transboundary rivers between the different countries. In Pakistan, as the water flows in the rivers, we have 4 provinces. So the provinces also raise concerns over the use of water. For example, the river flows from KPK and Punjab and then to Balochistan and Sindh. So definitely Sindh, they would like to get required quantity of water to meet its demands. So there was a conflict between the provinces of Pakistan over the use or sharing of the available water. So in 1991, there was an accord signed between the 4 provinces of Pakistan over the mutual sharing of water usage. So that is known as the Water Accord, 1991. So in 1991, an agreement to share waters of the Indus River was reached between the 4 provinces of Pakistan in the form of the Water Apportionment Accord. So this is known as Water Apportionment Accord. Apportionment means taqseem, distribution, taqseem. So this is known as Water Apportionment Accord, which was signed between the 4 provinces in 1991. So in light of the accepted water distributional principles, the following apportionment was agreed to. So you can see here that out of the available total water, you can see here that for Punjab during the Kharif season, 37.07 million acre feet. During the Rabi season, 18.87 million acre feet, so total 55.94 of the available water that has to be used by Punjab. Similarly for Sindh, and in Khyber Pakhtunkhwa, you can see we have 2 figures. The reason here is that in Khyber Pakhtunkhwa, we have civil canals. So it happens that some of the canals, they are maintained by the government. And some of the canals, they are maintained by the civil community, civil society. These are known as civil canals. So this is the water distribution during the Kharif and Rabi seasons. And you can see for Balochistan, during the Kharif season, 2.85 million acre feet, and during the Rabi season, 1.02 million acre feet. So under this water accord, the 4 provinces agreed over this water distribution. Water use around the world, you can see if we look to the picture globally. So globally for agriculture, we are using water 70%. 8% for domestic use and 22% for industrial use. So globally, this is the situation, usage of water. If we consider the high income countries, that is the developed countries, they are using 30% of water for agriculture, 59% of water for industries, and 11% of water for domestic uses. So you can see here that in developed countries, 30% of water is used for agriculture. And the reason here is that they are using more efficient methods of irrigation. As I show you some pictures in the start of this lecture. Whereas 59% of water is used for industrial use. But if we compare this with the low income countries, that is the developing countries, you see that developing countries, they use 82% of water available for agriculture. Because we have more population, we need to grow more food, and 10% of water that is used for industries and 8% for domestic use. This is given in this source. So industrial use of water increases with country income going from 10% for low and middle income countries to 59% for high income countries. You can see here that, for example, in Pakistan, we are a developing country. Agriculture is the backbone of our economy. And you can see here the water we are using for agriculture. Now we have studied the different sources of water that is available, that we have the rainfall, the surface water, and the groundwater. So then we defined an important area of civil engineering that is known as water resources engineering. So what is water resources engineering? Water resources engineering is that branch of civil engineering concerned with maximizing the social and economic benefits associated with the world's water resources that we just studied, while minimizing the adverse environmental impacts due to modifications to the natural environment. So this water resources engineering, it then covers all aspects of what you studied: the fluid mechanics, hydraulics, hydrology, irrigation engineering, groundwater hydrology, and so on. So it is that branch of civil engineering which is concerned with maximizing the social and economic benefits that are associated with the world water resources. What we mean by maximizing the social and economic benefits, you see that we use the water for drinking purposes, washing, cooking purposes. As the population increases, we are exploring more resources of water to meet the demands. And economic benefits. So we are using the same water for agriculture purposes to grow crops. We are using the water for hydropower production. You see that we construct dams, and there we can generate electricity by utilizing the head of water available. That can result into economic benefits. So on one side, we are maximizing the social and economic benefits, but on the other side, we are minimizing the adverse environmental impacts due to modifications to the natural environment. As you can see here, that when we construct canals and those hydraulic structures, we bring modification to the natural environment. You can see that Torbela Dam is the largest earth and rock-filled dam in the world. So we are modifying the natural landscape of the area. You can see that huge quantity of water is stored behind the dam, and this resulted into resettlement of the people used to live in the small villages in upstream areas. Because of the reservoir, those areas were flooded underwater, under the reservoir. So we have to resettle the people, and it was a conflict that continued for many years. You have to compensate. Similarly, you see that we bring modification to the natural environment in the sense that we are regulating the river flows. So because of this, the ecosystems that are necessary, they are affected. And that's why we say that downstream of the dam we have to keep minimum water in the river for maintaining these ecosystems which are known as environmental flows. Similarly, we extract the groundwater. So the groundwater which we are using again for different purposes also have environmental impacts. So in water resources engineering, on one side, we are maximizing the social and economic benefits while minimizing the adverse environmental impacts due to modifications to the natural environment. We supply the water to the crops. At the same time, we are maximizing the benefits from the crops. For that, we are using the fertilizers, pesticides, and they contain chemicals. And when you supply the water, that fertilizer, pesticides are sold in water. And if that water comes to a natural drain or joins the river, or due to seepage joins the groundwater, so it can result in adverse environmental impacts. So this is what we study in water resources engineering, and it deals with all these, maximizing the social and economic benefits associated with the world water resources while minimizing the adverse environmental impacts due to modifications to the natural environment.